So here we are talking about displaying simultaneous equations in matrix form. So you might remember simultaneous equations from year 10. So that's how we look at them, algebraically. Now you can solve those algebraically. However, you can also represent these as a matrix equation. Okay, so you can see that this sort of equation part gets represented as a 2 by 2 matrix and the answer as its own answer matrix. This, of course, becomes two matrices with the coefficients and our pronumeral part there. Why does that work? Well, think, negative, well, yeah, it does. Okay. So that's, when we have two pronumerals. What about here when we have 3? How do we write that? Okay, so I'm going to have, first off, a 3 by 3, a 3 by 1, and a 3 by 1. Okay, this first row, I'm going to have positive 2, positive 3, negative 1. So that's x, y, z. So you can sort of see here, well, we're 2 times x plus 3 times y times by negative 1 times by z gives you 5. Okay, then I've got 6. Now, this is what a lot of students do. They don't know what to do here when y is not there. Well, how many y's are there? None. So you write 0. 5. And that's 19. So 6 times x plus 0 times y plus 5 times z gives you 19. So negative x is negative 1, negative 2y is negative 2, positive 7z is 7. So negative 1 times by x plus negative 2 times by y plus 7 times z gives you 28. Okay, here I have this as these matrices, and we need to show them as simultaneous equations. Okay, so that is 3x minus 2y plus 1z equals 21. 4x plus 2y plus 0z, we won't write that, equals 34. Negative 4x plus 5y minus z equals negative 19. Okay, now we can put all of those into our calculator, of course, to solve, and that's where we'll get to with this. Now this is from the 2018 exam 1, question 5, so it's about medium difficulty. So Liam cycles, runs, swims and walks each day. Okay, each time he cycles, Liam covers a distance of c kilometres. Each time he runs, he covers r. Each time he swims, he covers s. Each time he walks, he covers W kilometres. The number of times that Liam cycled, ran, swam, or walked each month over a 4-month period, and the total distance that Liam travelled in each of these months are shown in the table below. Okay, so in month 1, he cycled 5 times, he ran 7, he swam 6 times, and he walked 8 times, and he covered in that month 160 kilometres. Okay, so month 2, he cycled 8, ran 6, swam 9, walked 7, for a total distance of 172 kilometres. Okay, so the matrix that contains the distance each time Liam cycled, ran, swam, or walked, CRSW, is... Okay. So, we want to figure out how much or how many kilometres he covers in each one of those. Let's write out all of this information as simultaneous equations. Okay. Now you'll have it in front of you. I'm not going to scroll backwards and forwards. So 5, 7, 6, 8, 8, 6, 9, 7, 7, 8, 7, 6, 8, 8, 5, 5 times by cycle, run, swim, walk, and then we get our distances for each of the months. So 160, 172, 165, 162. Okay, so here, just to talk through it a little bit, this is saying in this month, which is month 3, he cycled 7 times, ran 8 times, swam 7 times, and walked 6 times, for a total of 165 kilometres. Okay, we want to figure out what those distances are. In other words, we want to solve for C, R, S, and W. Okay, let's go to the good old CAS. Now, a couple ways you could do this. For now, let's stick with solve and do our matrix and X a 4 by 4. Okay, so 5, 7, 6, 8, 8, 6. This is why you have to do a lot of work on your calculator to get quick, but you also have to be accurate. Okay, times by matrix, which is 4 by 1. So C, R, SW equals to another matrix, 4 by 1, 160, 172, 165, and 162. And don't forget, we are solving for C, R, S, and W. Enter. Okay. So that means that whenever we cycle, we go 8 kilometers. Whenever we run, we go 6 kilometers. Whenever we swim, we go 1 kilometer. And whenever he walks, he goes 9 kilometers. Okay, so which one of these? It is option C. No, it's not. Option B. Oh, okay, so 42% of the state answered correctly. 18% answered E. 15% answered D. 14% answered A. So, yeah. So here, I think, with E being the most incorrect, I'm not quite sure what was done there. But here is an example of having to read really carefully what you are being asked to find. Okay, you're being asked to find the matrix that contains the distance each time Liam cycled, ran, swam, and walked. In other words, solving for CRSW. So that's what you had to do there.